Hi, grade 8 students. It's day 16 and 17. You'll notice that day 16 was a take a day off day. Day 17, we've got problems on 512, numbers 7 and 8, and page 516, numbers 9 through 31, the odds. Let's start first with talking about dilations on 512. What in the world is a dilation? Well, imagine that a dilation is simply either an enlargement of some sort of shape or figure, or it is the shrinking of some sort of shape or figure. For example, let's imagine I have a coordinate plane and I put two dots, one dot here and one dot here. And I tell you that there's a line segment between the two of those dots, and I give you the location of those dots as being 1, 3, and, 1, 1, and 3, 5. Location 1, 1, and location 3, 5. And somebody says, dilate that, and dilate it using a scale factor of 4. A scale factor of 4, or a dilation of 4. What do they want us to do? It's real simple. You take this first ordered pair, 1, 1, and you multiply both of the numbers by that 4. And so you get 4, 4. You take the second ordered pair, 3, 5, and you multiply both numbers of the ordered pair by 4. And you get 12, 20. And so what we're saying is that our new shape, in this case a line segment, is going to look something like this, and its dots are going to be at 4, 4, and the other dot is way up here at 12, 20, which is completely off the screen. Can we get that in there? There it is. So when the dilation is a whole number like 4, just simply multiply every value of the ordered pairs by that number and replot the location. But what if instead of the number 4, somebody says to you, dilate this using the number 1/2? Well, guess what? It's the same thing. Let's take the first ordered pair and multiply the 1 by 1/2. 1 times 1/2 is 1/2. 1 times 1/2 is 1/2. There's our first ordered pair. Take 3, 5, multiply those by 1/2, and you'd get 1 and 1/2, and you'd get 2 and 1/2. 3 times 1/2 is 1 and 1/2. 5 times 1/2 is 2 and 1/2. And the new location of our place for this dot would be here, approximately, and let's see, about here. In other words, in this time our line segment shrunk. It became about half of its size. So that's what you're doing in that particular page, page 512, numbers 7 through 8. Now what about 513, 514, and 516? Well, you remember that if we want to find the value of x here, that the sum of these three angles has to be 180. So if I take 50 plus 45 plus x, and if I figure out what x is, I'll have the value of that angle that's right up there. 50 and 45 is 95. 95 plus x is 180. What would x have to be? X would have to be 85 in this case. 85 degrees. Now, that's for three-sided figures, or in other words, triangles. What do we do for four-sided figures? The process is similar, it's just slightly different. We take the angles, and this time, instead of 180, because it's a four-sided figure, we use the number instead of 360. So 190 plus 70 is 260. Subtract 260 from both sides of the equation, x ends up being 100 degrees. this would have to be about a 100-degree angle. So if it's a triangle, make all the angles equal to 180. But if it's a four-sided figure, a quadrilateral, make the four angles equal to 360. Now we're going to put maybe a little bit harder of a problem in front of you here, but it's not too bad. What if you had this situation? One angle's 70, one is 110 degrees, one is 5 times x degrees, and one of them is x degrees. It's really not that hard. Watch. We're going to take 70, 110, 5x, and x, and we'll make those equal to 360, just like we said on the previous problem, because this is a four-sided figure. Let's add up these numbers to 180. Let's add up these numbers to make 6x. 5x and 1x is 6x. Let's subtract 180 from both sides of the equation. Let's divide both sides of the equation by 6. So x right here has to be 30 degrees. And if x is 30 degrees, what's 5 times x, or 5 times 30? The other angle has to be 150 degrees. Okay, let's do some identifying for a few minutes. Take a look at this particular shape, look in your book, and see if you can figure out, based on what it says on page 514, which one of the shapes this is. Well, you know what? I can give it at least 2 names. Can you? First of all, it's definitely a quadrilateral because it has 4 sides. Secondly, it's also a trapezoid. Why? It has one set of parallel sides. Which one would I name this? I'm going to name it the most specific name. So in this case, I call this a trapezoid. Let's try this one right here. I can think of at least 2 names to call this one as well. This is a quadrilateral because it has 4 sides, but it's also a parallelogram because it has 2 sets of parallel sides. This side is parallel to this one, this side is parallel to this side, plus the opposite sides are equal in length. Which one would I call this one? I'd call it the most specific name. I'd call this one a parallelogram. How about this last one? I can think of 1, 2, 3, 4, 5 different names for it. And all 5 of the names would technically be correct. This is a quadrilateral. This has 4 sides. It's a parallelogram because opposite sides are parallel to each other. It's also a rectangle because rectangles have 4 right angles. It's also a rhombus because rhombuses have 4 congruent sides. And finally, it's also a square because it's got 4 congruent sides and 4 right angles. All of the definitions that I just mentioned are true statements about this shape. Sorry, I'm picking up a drop pen. But which one of them would I name this one? Which one of the names I just talked about is the most specific? Well, that would be a square, of course. Hope this helps you in working through this assignment, but if not, please give me a call, 517-242-3138. Thank you, and have a great day.